Here we will be discussing medical applications for the Medical Mathematics 105 and it's Unit 6. Here are some pertinent websites. Let's take a look at what they have to offer. This first one says Math in Medicine. How is math used in healthcare? So you have what doctors do, calculating medication dosages. That's very popular, interpreting medical research. So that's why statistics is important. And CAT and X-rays and a wide other range of math-related procedures. This other website, let's see what it's saying. It says math used by respiratory therapists, but it begins now by saying the medical side of math. How is math used in the medical field? And you have a wide range of other applications. Now, these are not the only website with regards to mathematics in medicine. Okay, so you are free to research other medicine, but let's just be specific. Here we identify a first question, okay, because as we are doing, we are normally using an assignment as a learning instrument. Okay, so apart from notes in the assignment itself, we have some question, and here is an example. So the question saying a patient is ordered 90 milligrams of pethidine. Find the volume of required if the stock solution contains 50 grams of pethidine per milliliter, per 300 milliliters. So that's a question that might arise in your medical practices. And here's an example of how to solve such a question. This example was taken from this website. Just click on this website and you'll see the example. Example number, these are the notes, how to solve drug calculation. Example number 1, that's what we took. And there are other examples, number 2, etc. So it's also a learning device. You can use it to learn about. So we are going to discuss example number 1. So before going into the calculations, let's take a look at the formulas. It says to identify what type of drug calculation, and as a first step, use common sense to estimate a rough answer. Okay. In many cases, it's like using your intuition. Okay, drawing a picture that will visually represent the problem is often a helpful strategy. Remember that a formula often used by working on how many tablets to take or for a drug taken orally or injected is. So volume required, here is the formula. Remember that a formula often used to work out the number of drops per unit delivered by an intravenous infusion. Here's the formula for number of drops. And remember that for intravenous infusion, sometimes you are asked to calculate the volume, time, or rate, and the following formula can be useful for volume, time, or rate. And rate, volume is equal to rate of times time, rate is equal to volume over time, and time is equal to volume over rate. So here are the formulas that you have to apply, okay, depending on the question. So this question now is titled drug made up from a stock solution. Okay, so this example illustrates how to work out injections or orally taken drugs made up from stock solution. For example, working out how many milliliters to inject when the drug is in a stock solution. So your final answer have to be milliliters. And it says a patient is ordered 70 milligrams of pethidine. Find the volume required if the stock solution contains 10 grams of pethidine per 200 milliliters. Okay, so to work out these questions, you will need to know what you are asked, what you are required, exactly what you are asked, what you are required to answer. And the question is asking, find the volume. So we have to find the volume. So we have to use the volume equation. So when we, volume formula. So when you go up here, we are, here's the volume formula. And to use the volume formula, you need the strength. SR, you need the stock strength. SS and in the volume of stock. Okay, so do we have that? Yes, so that's it has identified that is the volume, that is the formula that we've got to use. Step number one is to note down the strength of medication the patient needs and the stock strength. So the strength required is 70 milligrams. It's ordered 70 milligrams here. Stock strength is 10 grams in 200 milliliters. Okay, so that's the stock strength. Okay, you see? So at this point, our rough answer is more than 1 milliliters and a lot less than 200 milliliters. Okay. So with experience, you'll gain that intuition. But in the meantime, let's master how to use the formula. So it says, since you need the units to be the same, convert 10 grams to milligrams. Okay, so here our answer is 70 milligrams. And the stocks, what is in stock now is 10 grams per 200 milligrams. So we have to do a conversion to have the units the same. Okay, so what was done now is to turn grams to milligrams. Converting grams to milligrams, we can use the ratio question, the ratio steps. Converting 10 grams to milligrams. So to convert 10 grams to milligrams, basically what you need to do is to get your labeling ratio, which is grams to milligrams, grams in small g, lowercase g. Now we need a starting ratio with two numbers. What's the rate for grams to milligrams? Conversion rate of grams to milligrams. Grams to milligrams, or mg, not mlg, mg. Sorry. Get the symbolization correct. And let's go back to check this out. So it says 1 gram is 1,000 milligrams. Okay, so 1 gram is 1,000 milligrams. So we'll use those two numbers as our starting ratio. So 1 coming on the grams and 1,000 coming on the milligrams. Okay, now what we've got 10 grams. And we're looking for X amount of milligrams. X is the unknown. So in algebra, whenever you see X, you can just say unknown. The word for this symbol is 1. The word for this symbol is 1,000. So the word for this symbol, X is unknown. So you can just say unknown. It's a variable. Okay. And we have learned it in graphs is the independent variable, unknown variable. Now, like a placeholder. So now we have to divide by the number diagonally from the unknown, which is 1. So we have to divide by 1 because now we are going to do cross multiplication and divide, because you have our labeling ratio, step number 1, our complete ratio, step number 2 with two numbers, incomplete ratio with a number and a letter, and now we are going to cross multiply and divide. We have to divide by 1. 1 is diagonally away from the letter X. And we have to multiply 10 times 1,000. So basically, 1 gram is 10,000 milligrams. And that's where this calculation came from. Okay, 1,000 times 10, 10,000. Now, for the first step, put the values into the above for, okay, meaning put the values into the formula. So for strength stock, you plug in 70. For stock strength, 10,000. And for volume, 200. And then when you work this out, 70 times 200 or 10,000 times 1, and then 14,000 divided by 10,000. 14 divided by 10 will give us 1.4 milliliters. Okay, so based on the above, your answer is equal to 1.4 milliliters. As you can see, ratios, specifically conversions, is prevalent in questions such as this because you are constantly having to, convert from one unit to the next. But basically, you simply have to always apply the formula. So if we take a look at example number 2 briefly. At first glance, you can see this example is the application of the drip rate formula. So to apply the drip rate, to calculate drip rate, okay, you need volume, drops, and time. Okay, and just simply apply the formula. Here you have a conversion taking place. Okay, 1.5 times 1,000 because you are converting from milliliters to liters. And then you apply the formula. And you have example 3, tablets taken orally, intravenous infusion, intravenous infusion. I know. And very interesting presentation with regards to the application of, and here are some exercises, and the answers are provided. But for this session, we only basically dealing with number 1, example number 1. And as you can see, it's just the application of these formulas, different questions.